Welcome to the Neotys Kitchen TV. So today it's a very special cooking session because obviously we are not at Neotys headquarters in the kitchen of Neotys. We are at one of our main partner called Computest. Computest won last year 2016 award, and I'm very pleased to present this session with Jurek. So nice to meet you, Jurek.
Hi, nice to meet you.
How are you?
Welcome in our kitchen.
Thanks.
Yeah.
I love the kitchen, by the way.
Yeah.
So today we are going to present something very special, and I think you wanted to talk to a specific topic.
Yeah, I want to talk about doing extreme load tests.
So what is extreme load testing, by the way?
Well, extreme load testing is not testing with 10,000, 100,000 concurrent users, but testing with millions of concurrent users.
Wow, million. And
millions.
What target did you achieve? What number of concurrent users did you achieve?
Last time we did a test up to 2 million concurrent users.
Wow, that is huge, I think.
Yeah.
From my perspective. But what is the context? What was the project? What was the objective and so on?
Yeah, the project was for a TV show, and the TV show expected more than 2 million viewers actually, up to 10 million viewers at the same time. And they expected users to use an application during the TV show, and they would be able to live vote during the show.
So voting, are you meaning, it means you have a very short time frame to vote?
Yeah, you have a short time to vote, and that causes big spikes in the environment.
So it means in a few seconds, 2 million people sending a huge request.
Yeah, so not only many users, but also many requests at a short period of time.
Okay,
yeah.
So I think it's a very interesting topic, and I think we want to share with you how to deliver that type of tests, and more than that, what are the challenges? And by the way, Jurek, what are the challenges?
Well, first of all, the biggest challenge is to have a sized load test environment with lots of load generators, because you need lots of load generators to simulate lots of users.
So the architecture of your load testing, the load testing architecture.
Yeah, it should be sized well.
Okay, so that will be the first challenge.
Yes.
And the second one?
The second one is the design of your virtual user, the design of the script.
Yeah, because obviously, as you probably, as a load tester, as a performance engineer, you know, once you extract variables or if you have any errors, that will make your script heavier for the load generators.
Yeah.
And last topic?
Yeah, something to consider is the planning of the day.
Yeah,
large tests can take lots of time.
Yeah, and a lot of people also involved, I guess.
Yes, yeah.
Okay, so let's see those challenges one by one by starting with the load testing architecture.
Yeah.
All right, so we talked about one of the challenges, which is the load testing architecture. So let's, before we get to your architecture that you've used, in any tests running with 50, 500, thousands, million users, in any situation you will need a controller. So Neoload is the controller, will be installed on an operating system, and this operating system, of course, is running on a hardware server or virtual server. And then, in any test, of course, you need also at least one load generator. Same thing, software-based, Neoload load generator running on an operating systems over a hardware. And in your test, did you use load generator hosted on your client side?
No, we used the cloud environment for that.
Okay,
cloud environments.
Okay, so it means you will have the cloud involved.
Yeah.
And how many load generators did you use here?
Well, for this test, for 2 million users, we used 800 individual load generators. 800,
but why did you use 100 or thousands of load generators, in fact?
Well, we needed to simulate 2 million concurrent users, so that many amount of users at the same time. And for that, you need lots of hardware load generators to support it. And the easy way would have been to start thousands of load generators, but if you do that, if you use too many load generators, the Neoload controller will start having problems with gathering all the results and processing the results.
And also we will talk about it, but each load generator has a connection with the controller. So
Yeah.
thousands of connections open, that's quite challenging.
Yeah.
And so what was the approach to find the proper number?
Yeah, the approach is to find the proper number. Like as I said, too many load generators will show issues on the controller, but too few load generators would mean a lot of users on the same load generators that could cause the load generator to fail to process all the users. So the approach was to start with smaller tests, obviously, and see what the footprint of a single virtual user is on the load generator.
Okay, so that test allowed you to find the maximum number of users per load generator.
Yes, yeah. So we figured out for this specific test, because it's also it depends on your setup of the test. In this specific case, at a point of 3,000 virtual users per load generator, the load generator started to be the bottleneck instead of the application that we tested was the bottleneck.
Okay.
So we found out 3,000 is the maximum. So we figured out to get a bit safer number to not get into issues on the load generator. We figured out, okay, 2,500, that's our number of users we want to deal with maximum on.
Okay, 2,000
Yeah.
VU. Okay, so now I understand very well, and I guess you also understand what was the approach to find the proper numbers.
Yeah.
And also secure the fact that you won't stress out your each load generator by one. Okay, but we talked about it. You will have 800 connections to the controller, so I guess you made something you make some changes or some settings on the controller to make it run a bit safer and more robust, I guess?
Yeah. Well, first of all, we started with sufficient hardware.
Okay.
So we used a machine with 64 gigabytes.
64 gigabytes?
Yeah,
wow.
and 32 cores.
Okay.
To handle all the communications. Next thing to consider is that every load generator constantly updates the controller with current values, like current response times, requests per second, etc.
The throughput as well?
The throughput as well.
Yep.
And that causes lots of throughput, so you need also sufficient bandwidth for this controller. So we choose the machine with 10 gigabits of network capacity. And then that's not all. We also tuned the controller by looking at different configurations that you can do.
Yeah. So for those who doesn't know, but there is a control of property files on the controller, and from there you can make a lot of changes. And what are the changes that you've made there?
The changes that we've made are, for example, we tuned the Java memory settings, so we said that it could be consume all the available memory of the machine, or else it would be stuck at 25%. That's not what you want. You want to be able to have all the memory so it can generate and process the results much quicker. And also there are settings to reduce the amount of updates it does. So reduce the network usage and reduce the amount of updates, so it uses less CPU too.
Okay, fine. And also the aggregation of the results, you've changed something also?
Yeah, we changed a bit. Usually we want to have as less aggregation as possible, but for this test we used a bit of aggregation, so it is able to it stores less data, because with so many users, if you store raw data, it gets in gigabytes of
results.
And analyzing the test would be unusable.
Okay. I think it's pretty clear. I mean, first, to summarize, finding the proper numbers of the LG required, and then from there, a couple of settings will be changed on the controller.
Yeah.
And I think we also, in a way to reduce the footprint of the VU, we need to have an optimized and robust script running on the controller, or on the load generator in fact. So let's see that. Let's see what are the area in the design you need to focus to make your script more robust and consume less memory on the load generators.
Yep.
All right, so now let's see how to optimize the design or make your script more robust. for extreme load tests. So Jurek, what type of recommendation do you have for that type of projects, especially in design as part?
Yeah, well, there are two main things that you can do to optimize your design. First of all, you want to really decrease the number of errors that your script will cause. And second, obviously, you want to decrease the resource usage by your script and by your controller.
In fact, the errors will help also to reduce the resources, because errors will just increase the size of the project and also the communication between the load generators and the controller.
Yeah. If you get lots of errors on the application or within your test, that will have a lot of impact on the resources in the controller, but it will also screw the analysis, because imagine if you only have 0.1% errors and you test with 2 million concurrent users, you will end up with thousands of errors per second, and that's not what you want.
So here, what I can see here from the Neoload report, you've done a tremendous work.
Yeah. We only had one error in this test, so we don't think that's significant. So but what we've done here is with preliminary tests, we tested the flow. So we optimized the flow that, for example, that all test data was 100% working. We worked here with 2 million individual accounts. So we validated them. Every single account worked 100%.
And did you implement any error handling in the design as well?
Yeah, we also implemented any error handling. But what you want to do is to minimize the error validations, because it will reduce CPU usage.
Could you show us this directly in the design section of Neoload?
Yeah. Well, in the design, what you want to do is to reduce CPU usage of the script. That's the main focus. For example, if you do an extraction in a script on a request, for example, this is a very easy, simple extraction that you usually have. What you don't want to see here is too many wildcards, because wildcards in regular expression can take up a lot of CPU usage. You want to avoid that.
So for those who doesn't know, in fact, variable extractors in Neoload is in fact behind the scene variable is regular expression. So here it's the advanced mode. So it shows directly in the screen the regular expression applied. What I would recommend for those who's using simple mode, I would definitely try to convert it into advanced mode to change or optimize the regular expression.
Yeah, will definitely reduce CPU usage.
And what about assertions?
Yeah, well, if you already have a regular expression or a variable extractor on a request, that is also by default an assertion. So you don't need necessarily have an assertion on this specific request, because every assertion will take up some CPU usage. So try to minimize that as much as possible too.
So for those who are not aware, every time we receive a response, we're not storing it. We only store the response in the memory if you have applied a variable extractor or an assertion. So if you put too many assertions, then it will mean that we will consume more memory on the load generator.
Yeah.
And
there's a lot more that you can do. There's a lot more that you can do to reduce the resources used by the script. For example, if you go to preferences of your project and you go to runtime parameters, there's an option called store previous response data on error. By default, that's selected, but for a big test, you don't want to turn that on. It will reduce memory usage significantly.
And what are the settings that you have done in Neoload in general, especially maybe on the runtime, that will reduce the memory or CPU consumption?
Yeah, on the runtime, you can go to scenario advanced settings, and there's a very important one. There's one, by default, it's selected. It's the display virtual user status during the test. And yeah, with lots of users, with hundreds of thousands of millions of users, you don't want to see the status of each individual user. If you turn it off, it will reduce the network usage and also CPU usage significantly.
Okay.
So yeah, if you reduce that, it would make a lot of sense.
And during the load testing architecture, you mentioned that you tune Neoload on the settings part. So could you explain the two files and the things that you've done quickly on the file settings of Neoload?
Yeah. Well, basically what you want is to not only tune the load generators, but also tune your controller. And one important setting is the Java memory heap size. What you want to do is that it takes the amount of memory that's actually on the machine. By default, it takes 25% of the memory you have on the machine. But because we selected a bigger machine, we also want to make use of all the memory it has. So if you look at the XMX setting, please use that so it can use all the memory it has.
And on the controller property file?
Yeah, on the controller property file, there's also some things that you can do. Is you have the compact part, which means it aggregates the data. For this specific test, we don't want it to aggregate actually, because we needed we wanted to know on every second how much we did. But for many cases, I can imagine that you can compact the data. So what you can do, you can compact the data to every 10 seconds. But it makes sense because it makes saving the results much quicker.
Yeah, in fact, by default, if you run the aggregation, depends on the duration of the test, in fact. So if you run a 10-minute test, you need a lot of points. But if you run a 48 hours or a 24 hours test, then of course, having less metrics makes sense because it will reduce the size of the results. So yes, aggregation is important.
So if possible, aggregate your results. So those are actually the basic things that you can do to quickly reduce resources during a test.
Okay, so reducing errors, reducing the footprint, and also a couple of settings around Neoload will be helpful and help you to run the tests in your platform without over-consuming memory or CPU or whatever it is. All right, so that's quite clear. So let's go to the last part, which is the organization. All right, so we've seen two challenges before. So how define the proper load testing architecture by defining the number of load generators and the tuning of the controller. Now we've seen also how to optimize your scripts or your user path by avoiding consuming too much memory or CPU on the load generator. And last, I think what is important also we would like to share is the organization of a test involving 2 million users. So what is there special about running a 2 million users test?
Yeah, it's obvious that you should be well prepared for such a big test. And one thing of the preparation should also be to do a preliminary test with, let's say, 10,000 users.
And what is the purpose of running a 10,000 user test? I mean, why don't you run directly to 2 million tests?
Yeah. Well, because probably you will end up in other issues of your own test setup or the application that you're testing. What you want to do before you start running such a big test is that you get a good feeling of your setup. So you do a test to test your own load generators and your test setup and see if you can scale, but also if the application that you're testing is able to scale. So you get a good idea, okay, with 10,000 users, we're running with this amount of hardware, it can scale, so if we add sufficient hardware on the application side, we will be able to run it.
And I guess you do some small fine-tunings on the architecture if required, of course. Because if you have problems with 10,000s, then it doesn't make sense to go further.
Yeah.
Okay. And then one other things you wanted to talk about is the time, I guess.
Yeah.
If you run a test with 2 million tests, I guess it takes a lot of time.
Yeah. That's the experience that we have is that it can take lots of time to start and stop a test because there are 800 load generators involved, maybe less, maybe more, depending on your situation. But to start a test, it starts to initialize all involved load generators.
So initializing a load generator means sending your scripts or your user path, of course, and the data sets to each of those load generators. So that could take time if you have lots of load generators.
So it can take tens of minutes to before it starts.
And then I guess the same things when you stop.
Yeah. The same thing is when you stop, but then it's not initializing, of course, but then it's gathering all the results. So once you stop the test, all load generator starts sending the data to the controller. That takes time because there's so much data, and after data is received, the controller starts processing that data.
So you need enough bandwidth, I guess.
You need enough bandwidth, you need enough CPU, and you need enough storage to store everything. And take your time and don't expect that you can run 10 tests on a day.
Yeah, makes sense. I mean, if you take so don't be too optimistic in your planning. Try to be secure by reducing the number of tests.
Take your time, plan well.
Okay.
Yeah.
All right. So I think it's quite clear. I mean, we have a fresh idea and good idea on how you can do that with Neoload. And I would like to thank you, Jurek, for this session and for
welcome.
This nice kitchen, in fact.
Happy to have you here.
Thanks. And thanks for watching. We will have a lot of great other kitchen cooking sessions that will soon be available. Yeah. And especially I think we could also maybe prepare something about CDN. I mean, if you agree to be part of that.
Yeah, CDN is a very interesting topic to talk about in details. Yeah.
So showing you how to test a CDN, what are the challenges like we just explained today, but especially with the CDN complexity. That will be a great topic. Thanks for watching and see you soon.
Thanks, bye.
Bye.